Have you ever wondered if a black hole could swallow the entire universe? An intriguing question, isn't it? Well, let's delve into this cosmic conundrum. Black holes, the enigmatic phenomena of our cosmos, are known for their immense gravitational pull. They're the remnants of massive stars that have collapsed in on themselves, creating a density so vast that even light cannot escape their gravitational clutches. These cosmic beasts can consume stars and planets and even gobble up other black holes. They are the ultimate cosmic predators. But what about the universe itself? Could a black hole, given its voracious appetite and insatiable gravitational pull, consume the entire universe? This question might seem like the stuff of science fiction, but it's worth exploring. First things first, let's dispel a common misconception. Black holes are not cosmic vacuums. They don't suck up space and everything in it. Rather, they swallow objects that venture too close. Gaurav Khanna, a black hole physicist, puts it succinctly: they only swallow things that are extremely close. In fact, black holes can only devour objects that venture into their event horizon, a black hole's point of no return, beyond which there is no escape. Yes, a black hole's immense gravity impacts surrounding stars and planets. It might even cause them to orbit, much like the black hole at the center of our Milky Way does, but it doesn't indiscriminately swallow everything within its reach. So if our sun were to transform miraculously into a black hole of the same mass, our Earth would continue to orbit in the same path. The gravitational pull would remain unchanged. Of course, it would get very dark and very cold, but that's a tale for another time. But could a black hole consume the entire universe, piece by piece? Let's explore. Black holes are former massive stars that have collapsed back in on themselves to become incomprehensibly dense. Born from the fiery death of a star, they are the celestial embodiment of extreme gravitational pull, so powerful that not even light can escape their clutches. Yet, contrary to popular belief, these extraordinary cosmic phenomena are not the cosmic vacuums that they're often portrayed to be. They don't suck space towards themselves. Instead, they command the space around them, bending the very fabric of the universe to their will. Picture it this way. A star, in its final moments, collapses under its own weight, compacting so much mass into such a small volume that it creates a gravitational well, a pit so deep that nothing can climb out of it. This is the birth of a black hole. It's not a vacuum cleaner indiscriminately hoovering up the universe, but a gravitational trap waiting for unsuspecting objects to stray too close. So how close is too close? Well, it's a matter of crossing the event horizon, the point of no return. Once an object ventures past this boundary, escape becomes impossible, even for light. The event horizon of a black hole with a mass equivalent to our sun would extend just 2 miles. It's a surprisingly small radius, right? For a black hole with the mass of our Earth, the event horizon would be a mere few inches. It's almost as if the black hole is saying, "Come closer, I dare you." Yet black holes are not all-consuming entities. They don't swallow everything in their vicinity. Their gravitational influence does affect nearby stars and planets, perhaps even causing them to orbit, but they don't consume them. The gravitational pull is something to be reckoned with, but the idea that a black hole could swallow the universe is a misconception. Black holes only swallow things that are extremely close, but how close exactly? Well, that's a story for another scene. For a black hole to devour an object, this object must venture into the black hole's event horizon. This concept, often referred to as the point of no return, is where the gravity of the black hole is so strong that nothing, not even light, can escape its pull. This is the reason for the black hole's namesake, as the absence of light creates a pitch-black sphere. Now, let's imagine the event horizon of a black hole, the mass of our sun. Picture walking just 2 miles, or about the distance of a leisurely half-hour stroll. That's how small the event horizon would be. It's a tiny fraction of the massive celestial body it represents. In another example, consider a black hole with the mass of our Earth. You'd expect an event horizon spanning thousands of miles, right? Well, prepare to be amazed. The event horizon of such a black hole would be only a few inches. Yes, inches, about the size of your thumb. This underscores the point that black holes are not cosmic vacuum cleaners, mindlessly sucking up everything in their path. They are, in fact, quite selective eaters. They only consume what comes within their event horizon, within that point of no return. While a black hole's gravitational pull can have significant effects on nearby celestial bodies, causing them to orbit the black hole, like planets orbiting a star, it doesn't mean these bodies are destined to be swallowed. The gravitational force exerted by a black hole is not a one-way ticket into its belly. So while black holes are indeed formidable and fascinating phenomena, they are not the all-consuming monsters often depicted in science fiction. They have their boundaries, and these boundaries are surprisingly small. Black holes may impact surrounding stars and planets, but they don't necessarily swallow them. They are, in essence, cosmic anomalies that both baffle and bewitch us with their mysterious nature. Their event horizons, their points of no return, are testament to their power, yet also a reminder of their limitations. Despite their incredible power, black holes are quite small. They may seem like cosmic giants, but in reality their size is quite deceiving. Picture this: a black hole with the mass of our Sun would only extend a mere 2 miles, while one with the mass of Earth would be no larger than your thumb. Yet their gravitational pull is so strong that anything venturing too close into what is known as the event horizon is doomed with no chance of escape. Now, you might be wondering, how close is too close? Well, it's not as near as you might think. The gravitational pull of a black hole does not suck in everything around it like a cosmic vacuum cleaner. Objects need to venture quite close to be captured, and even then the object in question must be aimed almost directly at the black hole. It's like hitting a cosmic bullseye. Consider the Sun and the black hole at the center of our Milky Way. For the Sun to be swallowed, it would take an astronomical amount of time for the star's orbit to line up just right with the black hole. So while black holes can indeed cause nearby stars and planets to orbit them, they don't necessarily swallow them. Black holes are like cosmic ballet dancers. They perform a delicate dance with the surrounding celestial bodies, influencing their paths and orbits, but rarely consuming them. They are not the cosmic gluttons we often imagine them to be. Instead, they are more like cosmic conductors, directing the movements of their celestial orchestra without devouring the players. Even the largest known black hole in the universe, the one named Ton 618, weighing an estimated 40 billion solar masses, appears to be near the theoretical limit of how big black holes can get. So, while they are powerful and intriguing, black holes are not the all-consuming monsters of the cosmos we often make them out to be. Even the largest known black hole in the universe appears to be near the theoretical limit of how big black holes can get. Then there is the universe's accelerating expansion to consider. A fascinating and ever-evolving puzzle, the universe as we know it is constantly expanding. As it unfurls, objects in space become farther apart, making the chances of them colliding with and being captured by a black hole less likely. This expansion is not a slow, leisurely stretch, rather it's an acceleration. A cosmic sprint that's widening the gap between celestial bodies at a rate faster than we once thought, and as these objects are flung further and further apart, their likelihood of being ensnared by a black hole diminishes. Now let's shift our gaze back to black holes, those cosmic behemoths that boggle our minds with their insatiable appetite. The largest known black hole in the universe, a gargantuan entity named Ton 618, weighs an estimated 40 billion solar masses. Even this cosmic titan appears to be near the theoretical limit of how big black holes can get. But why is there a limit? As these black holes gorge themselves on matter, they also release tons of radiation. This radiation heats up and ionizes the surrounding matter, making it more difficult for the gas and dust to cool down and fall into the black hole. This slows the black hole's feeding rate, creating a self-regulation mechanism. This radiation, in essence, is a black hole's own way of putting the brakes on its growth. It's a cosmic counterbalance that prevents black holes from devouring entire galaxies, let alone the entire universe. So while black holes are indeed formidable and fearsome entities, their potential to consume the universe is, in fact, self-limited. The universe's expanding nature and the black hole's inherent growth limits work in tandem, ensuring cosmic equilibrium. If one black hole were to devour the entire universe, it would require a monumental shift in the direction the cosmos appears to be going. This shift, given what we currently understand about the universe and black holes, is not just unlikely, it's next to impossible. The universe, it seems, has its own safeguards in place against such a cosmic catastrophe.